Okay, we're crack on. Okay, just make a start. I'd like to introduce Nathan, who's a game developer and scripter. He said say nice things about him, but I'll leave him to say nice things about himself, I think. And you're not doing a November thing for us. So typical game designer's goatee. One day he grows a full beard and then get older. So, I'd like to hand over, and I think this is an absolutely fascinating subject to talk about the futures of how we interact with the future, and why what we're working with at the moment is really just the beginning of a new revolution, I think. So, welcome to Nathan.
Thank you. Just to let you guys know, I'm standing in for Gavin Russell, who's supposed to be presenting. Jaja, J-I-J-A. Okay, sorry, I'm going to be looking at my notes as well. I did prepare, but I'm just not very good. Anyway, this afternoon I'll be sharing my view on the future of human-computer interfaces, as I feel that touch feedback is neglected in the current generation of touchscreens. I believe this missing link is required for us to have the advanced interactions with computers we require, as they become ever more capable of displaying and managing our information in new ways. I will be covering origins of human-computer interaction to define the basics, haptic feedback to explain the missing link, are haptics really the future compared to other interfaces, and the future of haptic interfacing to show you what to expect. The science of human-computer design, the science of human-computer interaction design was defined in the late 1970s when personal computers became available to consumers and areas of cognitive psychology were applied to PCs to address the needs of those users. Cognitive engineering was born from the cognitive psychology and computer engineering working together to define the basic guidelines. By 1980, computer advancements were in full swing and required human-computer interface researchers to define the idea that computer design needed to focus on understanding and empowering the user so that vast amounts of data being handled could be utilized and understood. Although the area of HCI is varied in its subfields, the slogan easy to learn, easy to use was coined, describing the process HCI research. This slogan helped influence future computer science and technological developments and give way for the computer interfaces we know today. What we've got here is a few of the interfaces over the years, beginning with the data point, which is the first keyboard to actually be connected with a computer terminal. And secondly, we have the first mouse, conceived in 1961 and created in 1963. In 1965, it was chosen by NASA to use their standard equipment. The Atari paddle and controller, which featured the first joystick, as we all know. The Magnavox featured the first games controller and the first commercial light gun. Fonz was an early arcade motorbike racing game that vibrated when colliding with other vehicles. The RAND tablet was one of the first graphics tablets available. Excuse me, I went far too fast, but I'll still continue. The RAND was one of the first graphics tablets available and featured an 11-inch square screen, an 11-inch square surface, and 1 to 100th of an inch accuracy with its stylus. Current interfaces are motion controllers, which are one-type remotes, which all use accelerometers and gyroscope technology. The PS3 Move is also tracked by the PS3 camera. Touchscreen interfaces offer the advantage of interacting with on-screen objects in a more direct manner than a traditional keyboard and mouse controller. Kinect is capable of interpreting gestures and full three-dimensional body tracking. Also features a microphone for issuing voice commands. Yeah. Excuse me, I need to retrieve a piece of paper. Connect. Then, after following Connect, is Leap Motion, a hand tracking device which creates a 3D space above the desk for the user to interact with and manipulate objects that are in the screen environment. There's a company called Immersion who demonstrated their haptic technology using an Android smartphone with a maraca shaking app. And basically when you shook the phone, the maraca would shake and you would get a vibration feedback, but it would also give you feedback for all of the little beans that are inside of the maraca itself. So it's quite an advanced haptic feature. From the current trends previously shown, it's important to note that two areas are prominent: gestures and feedback. If we focus on feedback, Immersion's vibrate approach is not really a haptic concept. It's just an advanced vibration tech. Excuse me. Modern smartphones use vibration functions to let the user know they've received a text or received a call when on silent. In addition, recent smartphones are using vibration functions to inform the user that they have input data. For example, entering a character on an on-screen keyboard will give you a vibration effect. Haptic responses are more complicated than vibrations matching on-screen events. Imagine only feeling a vibration to describe tactile contact with an object. You'll be missing descriptive information based on the act of actually feeling the object. Immersion's method, after a tactile reaction to the user, but detracts from the basic haptic interaction, because you can't identify the maraca if the sound is muted. This leads us to ask how a haptic interaction is defined. Haptic perception is the process of recognizing objects through the sense of touch. It can involve recognizing patterns touching the skin surface, for example, textures or curves, and hand positions in relation to the body when exploring an object to determine its size. And it can also allow you to recognize the shape of an object from holding it. The definition of haptic and tactile are sometimes the same depending on your source. I noticed that studies in touch identification consider tactile response as part of the haptic experience, treating tactile as a touch and haptic as the information received from the touch. The Child Learning Labs have conducted a set of haptic tests to determine if young children of preschool age use haptic skills to plan an action. The children were required to retrieve a toy from a tube by choosing the correct tool from a selection that varied in rigidity. The test discovered that children will use tactile skills as a method to understanding the test, but this is coupled with visual information to achieve the goal. Adult studies into haptic identification showed that when blindfolded and exploring an unfamiliar object, we use all of our fingers to gain an idea of how the object feels, its size in relation to our fingers spread out or wrapped around it. With a single finger, the recognition time was greatly reduced, in most cases due to the single finger mapping the object alone to feel its surface and size. Even with familiar objects, the single finger explanation will take a lot longer because we gain the best haptic response when our fingers all work together to assess what an object is. Excuse me. What's showing now is the adaptive technology that smart touchscreens with haptic feedback can actually give for the disabled. And we move on to children using haptic touchscreens to actually enhance their learning and give them new environments all in one area. And also adults using haptic touchscreens, which can avoid RSIs and increase efficiency and give more dynamic interfaces. Excuse me. Other areas that I have considered, I'm sorry, I have to go back a couple of slides.
Just push the back arrow.
Yeah. I've covered this. Okay. Right, and back to the end. Here I am. Please forgive me, I'll just continue. Other areas I've considered as the future of human-computer interface, in contrast to haptics, brain-computer and wearable gesture interfaces. Both of these areas have begun to make progress in human-computer interaction due to the fast-moving nature of technological developments. Sorry. Experiments using devices one and ahead of the user to detect electronic brain signals and translate them into actions on screen or by a robot. Advanced studies into spinal cord injuries and prosthetic limb control have enabled a primate to direct a mechanical arm and distinguish object textures using the arm's sensors, all via a brain implant. Wearable gesture recognition and tracking system called 6 Sense can project a computer interface onto any surface in front of the user and recognize real-world objects. 6 Sense tracks the user's hand movements and gestures to interact with the display and can project an augmented reality overlay to provide information on physical objects in focus. Both of these methods are useful advancements in the area of human-computer interaction, but still the basic need of haptic feedback from interaction is missing. In the case of the brain interface, I can see that for the disabled or paralyzed would be a great method and work well due to the reclaiming of abilities through the implant. When applying this to able-bodied users, the interface becomes intrusive due to the introduction of a brain implant when the user still has full motor and sensory abilities. As you can see from the side, haptics as a learning medium is important to us in every stage of our lives. Studies into haptic response have shown that we rely on touch and the actions we receive to make judgments in many situations. Having haptic-enabled touchscreens creates a truly responsive multi-tool platform for various users. Operating systems for haptic screens will have assistive controls for disabled alongside standard, so all users have the same experience regardless of their abilities. The dynamic properties of haptic screens makes it possible to simulate user-defined ergonomic interfaces such as convex keyboards or virtual wrist rests. Researchers at the University of Tokyo have developed touchable holography, where airborne ultrasound, Wii remotes, and a holographic projector are used to simulate basic holograms that have a physical form. The MEM table is a group meeting interactive touch table that captures users' physical interactions and digital data to assist in project management and evaluation of project life cycles. Nokia have developed a concept device named Morph, which features a shape-changing nano touchscreen that can raise buttons for the user, or solar charge or self-clean. Tampoma is a digital public map that can give you directions relating to objects you place against it. For example, if a bank card was used, the map would highlight the nearest cash machine or the bank the card belongs to. And to end, I have 3 ideas I think would come from haptic interface development. 1, it would be great to see haptic apps for touchscreens that allow the feeling of objects that the tablet camera is focused on. For example, a blind user would hold their tablet in front of them and basically enable the app, and the camera would record what is actually on the stream, and it would be translated into a haptic interface that they could feel, so they would know when they were coming up to, say, a curb or a wall or a fence, for example. Mixed reality computer interfaces using haptic feedback wedged with holographic projection. For example, a desk with haptic feedback surface to provide solidity and forces to 3D holographic projections that are used to represent data. Or this could be used to create virtual representations of objects placed onto the surface. And my favorite, the last. In the most advanced stages, large-scale haptic feedback environments will be available where users wear special clothing to react to electrostatic feedback and interact with holographic projections. I think that would be like a holodeck. Thank you for listening and enduring. Is there any questions?
How far away are we from seeing these technologies you know, in our world, because they all sound quite kind of advanced and kind of
Well, the haptic feedback on touchscreens, there's a company that's very close to doing that, as I may have actually covered. They have a cover that they can put over the screen and an integrated circuit that will actually work with all of the images shown on screen and be able to replicate the surfaces of those objects. For example, give you different textures and stuff. They're actually working on that now, and at one point there was a rumour that it was going to be on the iPad 3, but they didn't include it.
So we're talking about something that will give you, I'll run my finger over it and give me a different texture sort of.
Yeah, it's like you could feel an orange, or you could feel gravel. Not actually feel orange, you could feel the surface of the orange, feel gravel. You could actually feel the difference in elevation on certain apps or pictures even. One of the ideas I thought was having like a nature program where children are watching the animals go by and they can actually touch the screen and get a feeling of like, you know, what an elephant's skin would feel like, or the fur of a tiger, for example.
I mean, this is fine for the feeling of how objects vary in depth, but lots of objects, say in orange and gravel, have different hardnesses, which really contribute to the way the texture feels. So
that's true.
I mean, you could never really replicate fully the feeling of an animal or the feeling of.
No, it would be simulated. At the same time, like, you're right in thinking that you can't actually grip objects that are on a touch screen, but actually being able to feel the texture, and because of the way that the haptic interface is created, it would be able to give you a sense of if something's really rigid or if it has a soft surface, because it will give you feedback to actually go along with the actual visuals.
I think the question I have here, at the moment, is looking at it from flat surface point of view. Are they thinking about making it into three-dimensional objects? So rather than having something that you scan on a flat, but something that you hold?
There are people doing the research into that. It's not really far enough for me to bring it into the paperwork. But there are, Microsoft are working on holograms that react to your touch, but you can't actually feel the interaction. It uses infrared and a small holographic projector beamed off of mirrors. I think it's called Vermeer, which is amazing, and it would be something I included, but I didn't want to include it just to get, you know, an idea of that when it goes too far from the actual interaction. That's more just like a projection at the moment.
Yeah.
There are some good advancements.
How would you simulate the touch of a knife or something sharp? Is it actually physical presence that could damage your hand?
I think it could be, but the way that technology is designed today, they make sure that, you know, there's certain elements of it can't actually be, even though you could use an iPad as a weapon, you're not going to cut yourself or anything like that. So it's okay for children to, like, you know, run their fingers around the edges. And I think it'll be the same with the touchscreen technology, where they will allow certain things to be represented, but not as realistically as they should be, or they could be.
And what about the
At the same time.
Yeah, carry on.
the sensory, like the brain interface? Isn't that bordering on mind control?
It's from the studies that they've done, they using the brain implant with the primate. It's an interesting way for them to actually get the primate to be able to interact with robots like teleoperation. But with the actual controlling of the brain, it's not actually in the correct part of the brain, it's just in the sensors that actually record what you touch and stuff like that to get a picture and stuff. It's not far off it, I don't think. So I think it was two in the back anyway.
Do you see this as revolutionizing sort of the way you think people use data and electronics?
Yeah, definitely. Just thinking about the possibilities with the screens, just having, like, for example, a disabled user who can't actually use a game controller at all. Now they've got an interface which can actually make buttons that are suited to just them and their specific disability. Yep, at the back.
That brain implant thing again. Yeah, I was wondering, like, how is it something that is definitely going to happen, or is there going to be a point where we don't want to put implants in our children's heads so they can play the next tech? Like, is there a point where we say no, or do we always just progress and progress and progress?
The research that was done with the primate was mainly for disabled users and people that have been in accidents or spinal cord injuries. So people that have that have lost the use of limbs already, and they know basically what they should do with those limbs, but they just can't. So they use that as a way for them to control.
So it's like, I'm talking about, like, I don't know if you know, like data sets.
Oh.
Like augmentations where they're talking about, improving the life and that kind of stuff. But yeah, like.
I think they'd only actually go in that direction. I don't think they will go in that direction until people actually request things like that. I think right now it's mainly to help people that aren't as able as everyone else, to actually give everyone the chance to interact with things on the same level.
Yeah, I'm interested in the Nokia Nano thing. That sort of suppressed sort of, I don't know, 5 years ago when it first came out. I don't know if anyone knows this. It relies on smart technology. It's nanotechnology, and it understands, it's going down to the sort of micron level things, and it can change its shape and how it reacts to the environment in real time. But it seems to not, I don't know if they've ever built a real one, and I wonder whether nanotechnology is very interesting and could have a lot of permutation to this. I just wonder if you could sort of give it up with it, with this sort of technology. It always seems to be in the background. So it's like,
it's true.
Do you know if they've sort of tried to push it forward? Because Nokia's
Yeah, I don't think they've made any advancements with that exact piece of hardware. I know that from doing the research, there are companies that are still working on nanotechnology and actually putting it into technology that we already use to get new ways for us to use them and to new intuitive interfaces as well. Yeah, it's not something that I think will be around for go as far as guessing like 50 years.
That phone is really cool. You see the video on YouTube.
Yeah, it's great. Yeah.
Where you just embrace it and it can mimic anything you take a photo of.
It's true.
It's very, very odd.
Yeah. And it seems like it'll be a nice way to handle your technology.
The phones look nice.
Yeah, it does look great.
I mean, in some ways, the things with the feedback and all of this stuff, I mean, if there was like it seems like there's a chip that's able to send you sensory information, in your brain, or it seems like that would become a dominant. Again, if people accepted it, it seems like you could get really realistic feedback from that sort of thing, because it's not just the control. I mean, I assume it's understanding the signals you send, whereas this chip could send you signals based on what you've done with a piece of technology. So make you feel an orange from holding a phone or something like that.
So you're getting confused signals or something like that. I really think though, with regards to as we are now, as humans, no one really wants to have augmentations that change them in a way which is sort of non-human. And I think advancements in haptic touchscreens and haptic interfaces is probably something that people will invite more, because they don't actually, it's something that they use instead of changing them. It's creating a tool instead of turning them into a new type of tool.
So I think when you look at the iPad, one of the problems is it's just smooth glass, and you don't get a feeling of using something. So if you're typing on an iPad, it's a different experience to if you're typing on a keyboard. You can feel a keyboard, you can position yourself around it so you can touch type, where touch typing on an iPad is quite unnatural in some ways. You don't get the same feeling about it. So I think the visual you had where they were introducing an overlay so it can read Braille and things, where you can start to feel through that, is a great technology. But how does it work? Does it work from the light coming up, or does it interpret a computer signal going into it as an overlay, or will it be a separate device?
Electrostatic reactions from us touching the screen.
Right.
And it basically can repel our fingers from the screen. So you would be able to simulate a button and then the edge of the button where your finger has to fall off.
Yeah.
Yeah, and that's basically the way of the technology. And having, being able to simulate that on a really small level will give you the ability to do things like carpet or clothing,
Yeah.
just from the way that it's arranged.
So I think it's about the feeling of using these devices is the trouble. Because the trouble I have with the Kinect is you don't get any feeling.
Yeah, that's why I don't really favour it as a proper control medium for games, because you don't actually get any feedback, and you sort of feel like you are literally just standing there waving your arms about in the air.
Yeah.
Whereas with a games control, it's quite directed. You know what you're doing. You know what the buttons do, where to do things on screen.
Yeah.
There's a break in the.
Yeah.
How much do you think this will sort of lend towards education?
I think with children, it could be a great way for them to learn. For example, I'm sure everyone remembers like doing puzzles as a child, and actually having puzzles with large pieces or maybe tactile surfaces, that can all be simulated on a touch screen, as well as having things like interactive stories that involve the child actually touching certain textures and stuff like that. So it can be worked into learning from any age really.
So how's this information recorded there? So say you wanted to use it to have the feeling of stroking a tiger. You would sort of have to go and scan a tiger's skin and get, is it derived from 3D information that's then turned into an electrostatic signal? Or?
Yeah, I think it comes from us actually researching into what things feel like and learning how to recreate them with electrostatic feedback. Because no one's actually used this technology properly, it's available, but they haven't actually let anyone use it outside of their labs. But I think that's the way to look at it.
So do you think we have a texture artist? Do we have a feeling artist?
Yeah, we'll have a haptic artist, or someone who goes along and says, no, that doesn't feel like it should.
It don't feel right. Any other questions? One more?
There was an example quite a while back with the release of Battlefield 3. It was like a Battlefield 4 speaker, and there's just like this input where they put this guy in like rooms, it's like a panoramic screen, and they had sort of traditional sort of setup with a gun and sort of that, and he was playing the game. And whenever he got hit in the game, hit himself and fire to that point that he got hit in his body. So I'm just thinking, how far is it going to be that this sort of experience that we're talking about? Are we going to take the extreme and get pain and pleasure and stuff like that? I mean, is it really going to come to that?
I think like with the knife example, there'll be certain things which they'll leave out because they know that it'd be too extreme or have an adverse effect on us mentally. But like things like having different hit areas on the body, like having a suit that was responsive to electrostatic electricity and being in an area which could actually give those signals and respond to, you'd feel a lot of reaction from a lot of different things.
Is this technology
Within a touchscreen, yes. One thing they've also said about the technology to get the haptic touchscreens is that it can be applied to any surface. So you could actually have a wooden desk with a haptic space on it for your keyboard, for you to actually manipulate things on screen. It's not just tied to screens, but I think it's the best application for it because it's like a one-to-one perspective, you could say, in usage.
You say these things are like tied to circuits. So like, I mean, it's on a screen and it reads. It reads screen data to allow. Like, is it just reading finger data or is it reading screen data as well?
It's outputting screen data and reading the inputs from our fingers.
Right, so would it be possible to make like something wearable from it, which actually reads its data from an external source, which would, like, say, I don't know, say for an example, like a games console, instead of having a paintball fire at you, would it be possible to have like a wearable thing on this thing, and so, you know, not necessarily for games, but for anything that would take signals from something else and then apply them to you? Is that something that could?
There would definitely have to be. There would have to be some sort of chamber, because you wouldn't be able to just sit in your home with the electrostatic outfit and have reaction. And there would need to be something which gives out the gives out the charge which the suit or your body would react to. So I think it's a long way before we have, just these type of interfaces in our homes, unless we've got space to have a large room with lots of electrostatic sensors and,
Okay.
Anybody?
One last one.
Is there not like a worry where the sensory control maybe somebody hacks it or something and it actually causes bodily harm?
When I was doing the research into the haptic touchscreens, someone from their lab was saying how that they could actually they could stop your finger from moving on the screen, and he was saying how it was one of the strangest sensations he's ever had. His finger being stopped, but not actually knowing what was stopping it. So I think they are actually considering the sides that could actually harm you or actually give you some sort of RSI from being attracted to something too much. But when it comes down to it, with all human-computer interfaces, they go through a process of testing it on humans and doing stress tests and stuff like that to find out. So I think there will be lots of tests done. It all depends on them making sure when they're actually programming these interfaces that they don't actually let them go too far.
Okay. Wind up this. Thank you very much.